Hey guys, Mr. Mills is here. Today we're going to look at trapezoid and kites notes. At the end of this video, you should be able to use the properties of trapezoids and kites to find missing side lengths and angle measures. Okay, remember a trapezoid is a quadrilateral that has exactly one pair of parallel sides. An isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. Okay, a kite is a quadrilateral with two pairs of adjacent sides congruent and no opposite sides congruent. And then of the quadrilaterals we study, these are the only ones that are not parallelograms. Okay, so all the properties of parallelograms, none of those properties transfer to these figures. Okay, so let's talk about the properties of these figures. Okay, in a trapezoid, the base angles of an isosceles trapezoid are congruent. Okay, so in an isosceles trapezoid, the base angles are congruent. So in this example, they want us to identify the base angles that go with angle B, then find the measures of each angle. Okay, so when we talk about base angles, we are talking about the angles. Well, there are actually two bases to our trapezoid. Let's say that. Okay, so this is base 1, and this is base 2. So when we talk about the base angles, we're just saying, okay, let's look at the ones on base 1. Angle B is associated with angle C. Okay, these are both on base 1. Okay, angle A is associated with angle D. These are both on base 2. In an isosceles trapezoid, which they're telling us that this is an isosceles trapezoid. Let me make sure I tell you that. Okay, then we should be able to find, or actually, we should be able to say, what these values are then. Since the base angles are congruent, since B is 102, C has to be 102. I'll start there. Okay, now we have parallel lines and we have a transversal that goes through parallel lines, so we can use our same side interior angles theorem to say these must be supplementary. So if angle B is 102, then angle A is the rest of 102. That gets us to 180. So A then is 78. Angle D, since it's associated with angle A, it's on the same base, angle D must be 78 degrees as well. Okay. Number 2, the diagonals of an isosceles trapezoid are congruent. Again, notice that it's an isosceles trapezoid. It's not just a trapezoid, it's an isosceles trapezoid. Are congruent. Okay, and so we can go through a proof here to kind of hopefully cement this in our mind. ABCD is isosceles trapezoid, is what's given. Okay, then let's prove that these diagonals, we want to prove that AC is congruent to BD. We can say from the beginning that AB is congruent to CD, DC. That's also given, marked for us already. And then we can say, because it's the isosceles trapezoid, that angle DAB is congruent to angle ADC because base angles of an isosceles trap are congruent. All right, so I can say mark that out, and really what I'm going to do, I'm going to use that, kind of separate these two triangles, because I want to prove that BD is congruent to AC, but I want to do that with a triangle proof here. And so ADC. So I already know that AB is congruent to CD. Okay, I've just said that this angle DAB has to be the same as angle ADC. Okay. All right, and then I can say that AD is congruent to AD. Or AD is congruent to DA, I guess is the better way to say that, because of the reflexive property. Okay. And so what you should notice here is, hey, we've proven that these two triangles are congruent to each other. So triangle BAD is congruent to triangle CDA because of side angle side. And so now I can prove that those diagonals, AC is congruent to BD because of CPCTC. Remember, that stands for corresponding parts of congruent triangles are congruent. All right, so all that to say, these two important properties of an isosceles trapezoid. The diagonals of isosceles trapezoids are congruent, and the base angles of isosceles trapezoids are congruent. Those are two things. Okay, so we'll do an example and a proof, trying to get that locked in our mind. Okay, let's talk about kites. All right, the diagonals of a kite are perpendicular. The diagonals of a kite are perpendicular. So we can use this to find the measures of the indicated angles. So when we talk about perpendicular, remember that means they meet at 90 degrees. Boom. That means all of these would be 90. Okay? Only one of them is measured or angled is labeled for us. There we go. It's 90. Boom. Okay. Now we can find the rest of these values though. Since this is 90, we know that all triangles should add to 180 degrees. So I have 90 plus 32 plus angle 2 should equal 180. That's 122. So that gives us 58. Angle 2 equals 58 degrees. Okay. And then they're asking us to find the measure of angle 3. Now this one could be tough because, yeah, we have this at 90 degrees, but like, what is this? Okay, what is this measure? Okay, and what I want you to see is that when we look at triangle ABC, and I'll just draw this here, it's a kite. And we know that these two sides, these adjacent sides, are congruent to each other. Because they're congruent, we have an isosceles triangle. Okay, so in this isosceles triangle, since I know it's isosceles, I know that their base angles are congruent. We just found that angle 2 is 58 degrees. So we would know here that this is also 58 degrees. Okay, so in this triangle, I could either go back here knowing that's 58, or I could solve this and subtract 32 from it. But now I can find the measure of angle 3 pretty easily in different ways. Okay, and either way that I find it is going to be 32. All right, next example, it says prove that angle 1 is congruent to angle 2. Then find the measure of the indicated angles. Now, when I look at these two triangles, they already give us some information here that, hey, this is a kite, right? Because if it's a kite, then this is the information that we know, that the two adjacent sides are congruent and no opposite sides are congruent. But if I want to prove that angle 1 is congruent to angle 2, I can be a little bit creative and say, okay, well, let me make this into two triangles. I get better with my straight lines. Okay, so if I make this into two triangles with this line, then I can say, hey, this has to be congruent because of side, side, side. So the two triangles are congruent by side, side, side. And therefore, I know that angle 1 is congruent to angle 2 because of CPCTC. Corresponding parts of congruent triangles are congruent. Since these two triangles are congruent and angle 1 and angle 2 are in the corresponding positions, they must be the same. Now, knowing that they're the same, I can solve for their value. Let me just call this x. And say, okay, in a quadrilateral, we know that all the angles should add up to 360 degrees. So I have 59 plus 87 plus x, or 2x, equals 360. So it's at 146 plus 2x equals 360. 2x then will equal 114, or 214. Divide by 2. X is 107. And that means both of these angles are 107. Okay. Last one that we're dealing with these notes is the trapezoid mid-segment theorem. Trapezoid mid-segment theorem. A mid-segment of a trapezoid is a segment that joins the midpoints of the non-parallel sides. Non-parallel sides of a trapezoid. Okay, the mid-segment of a trapezoid is parallel to the basis. Its length is half the sum, so it's not just half 35, it's half of the sum of the bases. Okay, so here we want to find the value of x. X is the mid-segment. To find x, I could say EF equals half the sum of AB plus DC. So you notice I'm taking base 1, base 2, and adding those together, and then multiplying it by half. So x equals 1/2 21 plus 35. That's 56. Half of 56 is 28. Okay. The next question says, if angle A was 100, there's some scratch from last time. If angle A equals 100, what is the measure of angle DEF? So DEF, talking here. Okay. What they're questioning here is that we understand that this mid-segment is parallel to the basis. If it's parallel to the basis, what do we have here? We have corresponding sides. Okay, so if angle A is 100 degrees, then DEF would be 100 degrees as well, corresponding angles. Okay. Again, that's because corresponding angles basically in the same position. This is, if you think about the 4 angles here that are created, this is the bottom right. If you think about the 4 angles here that's created, this is the bottom right. They're corresponding, they're equal. And then finally, if the measure of angle C is 75, so I'm going to do this in red or magenta. The measure of angle C is 75 degrees. What is the measure of angle EFC? EFC right here. Okay. What is the measure of that angle? Okay. So, as we look at this, a couple things we can do. These are parallel lines, right? Still parallel, still asking us that, making sure that we understand that. And so these two angles are same side interior angles. Since they're same side interior angles, we know they should add to 180 degrees. Okay, so 75 plus Z equals 180. Subtract 75 from both sides. Z equals 105. All right, so that's trapezoids and kites. See ya. One more thing, sorry. Trapezoids and kites, but please notice that when we talked about a generalized thing for trapezoids, that we dealt with isosceles trapezoids. Okay, so a lot more to do in general with isosceles trapezoids than with trapezoids at large. Okay, all right, now see ya.